Question 5 is asking us to find all critical values of the given equation f of x equals the cube root of x squared minus 4x. Critical values happen in two places. The critical values occur when our first derivative equals 0, so when we plug an x in is equal to 0, or they happen when our first derivative is undefined, basically when math breaks. And that usually happens when you're looking at sort of a division by 0 situation. That's kind of the big one in this class to look out for. So what we'll obviously need to do first in a problem like this is go find that derivative if we're going to be able to find when it's equal to 0 or when it's undefined. When we go up to look at our problem, we always stop and kind of address the situation, and what we can see happening here is that we've got a rewrite that we need to accomplish. So always look out for any little algebraic rewrites before you just go jumping in to take your derivative. And this one is happening because we've got a root going on in our problem. Whenever we've got some root in our problem, it's x to some root with some power here. We rewrite this as x to the power divided by the root. So if we had something like the cube root of x to the fifth, we would want to rewrite this as x to the power of 5 over the root of 3. The most common one to see is a square root, which conveniently has an unwritten 1 as the power and an unwritten 2 as the root, and that would be rewritten as x to the power of 1 over the root of 2. Going up to our problem and looking at what we have happening here, how you have to look at this is all of this stuff is inside the cube root here. So all that stuff, think about inside a parenthesis. And so really what's happening is there's an unwritten 1 for our power there on all that stuff inside our root. So when we come to rewrite this using the power over root, this is going to become x squared minus 4x, and then this will be to the power of 1 over the root of 3. So that right there, that was just a rewrite only. We haven't taken any derivatives yet. We're just changing it up so that we can take a derivative. So looking at this problem, we now have to say to ourselves, okay, from all of our different rules, chain rule, product rule, quotient rule, what does this rule look like? And so here what we should see is we have something raised to something. And so this was a classic setup for a chain rule whenever we saw this. Something raised to something where I have an inside piece and I've got an outside piece. And my little saying that I like to use is d in times d out, the derivative of the inside times the derivative of the outside. That's our chain rule right there. So that's my recipe for the chain rule, and in order to apply it, I just come over and I label out my chunks to begin with. I break it into bite-sized problems, really. So the inside piece is all that stuff inside that exponent. So right now my in would be the x squared minus 4x. The outside piece is really just all this 1/3 power here. So the outside piece is a set of parentheses, all that junk to the 1/3 power. Now to do my chain rule, I have to go find the derivative of the inside piece and multiply it by the derivative of the outside piece. So the derivative of the in, this is just going to be my power rule. My power rule says bring the power down and then subtract 1 from the power. So I bring that 2 down in front, subtracting 1 from the power. 2 minus 1 would just give me a 1 right there. And then the derivative of negative 4x, there's an unwritten 1 as the power here that I'm going to bring down and multiply by negative 4. So that's going to give me negative 4, and when I subtract 1 from the power in that situation, I'm going to get x to the 0, and anything to the 0 power is always just 1, so I don't really need 4 times 1, so I'll leave that out. So there is my d in. And now I'm going to go accomplish my d out, the derivative of the outside piece. So this is really just a big power rule. I'm going to bring this 1/3 down in front. I'm going to leave alone all the stuff on the inside there, and then I'm going to subtract 1 from the power, which would be negative 2/3. And it's good to keep these things as fractions, and sometimes people forget that you've got a calculator here. And so if you have problems doing some of these fractional exponents, when I do 1/3 minus 1, I can type that into the calculator, hit enter. It gives me out a decimal, and if I hit math here and then number 1 in that menu option, which is frac, it's going to take that answer and turn it into a fraction for me. And so then it's going to tell me that it's negative 2/3. And that's really more helpful when I'm going through a problem like this. So I know that I'm looking at a 1/3 raised to the negative 2/3, and what stays inside those parentheses is just the same stuff that started in there, an x squared minus 4x. We already took that derivative as a part of our dn. So finishing up, getting our derivative put together, our f prime of x right now. Our derivative, our chain rule, was equal to this little recipe, dn times d out. So I grabbed the dn would be 2x minus 4. Then I'm going to go grab the d out. So the d out is this chunk here, which would be the 1/3 times x squared minus 4x, all to the negative 2/3 power. So now that we have our derivative, we need to find our critical values. And so our critical values happen whenever this derivative, our f prime of x, is either equal to 0 or is undefined. The easiest way to do this, especially when you're taking a multiple choice math test, is really to just let the calculator do the heavy lifting for us. What we're going to end up doing here is we're going to take this equation that they gave us, that we just got ourselves, our derivative here. We're going to take that, we're going to plug that into y1 on our calculator. From there, we're going to graph it, and then we're going to do a few second calc, and then we'll choose number 1 in that calc menu, which is values. So we're going to go through this set of steps on the calculator, and the values that we're going to check, the x values that we're going to plug in, are going to be the x values from our answers that they give us. Again, it's really nice to take a multiple choice math test. Whenever you end up getting out of here, if you end up getting a y equals 0 out, well then that's telling us when our derivative was equal to 0. And if we end up getting out a y equals and it comes back blank, there is no value there, well then that's going to be our undefined situation. So if we get either one of these answers out after we're calculating a value, then that value is going to count as a critical value, and that'll help us define what our answer is. So we're going to go to our calculator. You're going to hit your y equals, and then in y1 we'll type our derivative that we put together ourselves, which would be our 2x minus 4, close that parentheses, and then 1 divided by 3, close it, and then x squared minus 4x. Close that, and then raise that to the, no matter what you're doing, if you've got one of those older calculators, make sure you put this exponent in parentheses, negative 2/3 when you go to raise it. You don't need to on the newer calculators, but if you're doing it on an older calculator, make sure that you do it there. So then we did the first step, put this into y1. Now we're going to graph that equation. So we hit the graph button. And they give us our graph right there. And now we're going to go through these next set of steps a few times. So second calc. So we hit the second button and then choose the calc menu, which is up here above the trace. And then we want number 1 value. And now the x value we care about, we're just going to work our way through the answers. So answer A says x equals 2. So we'll type in 2. And out of there we got that 0 was our value there. So that meant when we plugged 2 into our derivative, we got out 0. So that's our critical value example where we plug in the value and we get 0. So 2 right now is a critical value. So if we're listing off our critical values, we know that x equals 2 is a good answer. And so we can at least narrow down that it's not option C right now, because option C doesn't include the number 2. Let's go on and we'll try option B, which adds in this answer of 0. So we'll do the same thing. This time we're going to go through and calc the value at 0. So we'll hit second calc, and then we'll choose number 1 in there in this, which is value. And this time our value is 0. So we type in 0, and we get out a blank. This is the idea of f prime of x being undefined. Our derivative is undefined at 0, so therefore it is a critical value. So we have another critical value happening at 0. So we've got 2 critical values now, x equals 0 and x equals 2, which means A can't be the right answer because it's not including 0 right now. So B and D both have 0 and 2, 0 and 2. And so now the last thing to check is x equals 4 and see if that's a critical value or not. So we go back to our calculator and we hit second calc, and then choose again number 1 in that menu, value. And then this time we'll enter in the value of 4. So type in 4, hit enter, and we get another blank out here. So this is another example of an undefined critical value. So we know that x equals 4 is also a critical value. So then the answer can't be B, and it has to be D, because we found that all of our values 0, 2, and 4 were critical values of our equation. So take advantage of a multiple choice math test. Do the heavy lifting yourself, which is you got to find that derivative, but then from there you can really let the calculator do the rest of the work for you so you don't have to go through a whole bunch of algebra by hand.